Good morning to everyone. In today's video, we are going to see the interconnection of two-port networks. As we discussed in our previous videos, two-port networks are nothing but the network which consisting of both input as well as output port terminals. So here we are going to consider the interconnections. That means if two networks are interconnected, maybe it is connected in series or parallel or cascading formation configurations, which parameters will be affected, and which parameters gives the in detail explanation of those connections we are going to see in today's video. So now we are going to see for the series connection. In coming classes we are going for our parallel as well as cascading connection in single step itself. So now please understand this series connection carefully, because this is the basic. If you are understanding the main concept behind this, the remaining ways of connections are just a simple equations. That's it, simple equations. So please look here. This is our black box. In this black box we are going to connect the elements. Already we know that one. So here in this black box I am considering two networks. One is NA, N suffix A, and N suffix B. So for ease of understanding, I say that network A, network B. For series connection, so whenever the word here series, the first thing strikes to our mind is the current flown through those elements are same. That means in the circuit, whatever the elements are there, the current will be same. At the same time, whatever the voltage connected across those elements, it should be equals to the voltage drop across the elements. Across the elements. These two are the conditions for series. Whatever may be, whether it is for a resistors or inductors or whatever may be the elements, it is common. So we are not deviating that thing. The same thing we are following here also. So consider this network NA and NB. So outside this black box, the terminals are same. We are having two port. So V1 is your input and V2 is your output. And so whatever the input voltage, it should be equals to the input of your network NA as well as network NB. A similar fashion, your output V2 should be equals to your output V2A and V2B. That is the two conditions regarding to your voltages. And the next one, what is the current? So whatever the current flown through your input terminals I1A, it should be equals to your I1B. Then only I say that the current sort of condition through in series, it should be satisfied. Similar fashion for your output terminals, I2A should be equals to your I2B. These are the conditions. Please understand the conditions. To satisfy your series connection, these conditions should be satisfied. Now as step number 1, so we have to write the individual parameters first. So once we got the individual parameters, after applying your conditions, you can get the overall parameter. It should be, then we can discuss what will be the thing. So now I am just writing the Z parameters for network NA. So we know that for Z parameters, which is the dependent variables and which is the independent variables. We know the dependent variables are the voltages and the independent variables are currents. So we know that for Z parameters, V equals to Z matrix into I matrix. So here I have the two port voltages, Z parameters and currents. So write the input and output equations. So give the number 1 and 2. Similarly, apply the same thing for your network A and B. So network B, so NB. So here also we are following the same thing. please understand one point. We are modifying the equation by giving the suffix a for the network NA and suffix b for the network NB. That's it. The rest of way of expression, all those things are same for both the network NA and network NB. The only thing, you are using the suffix a for the network NA and suffix b for the network NB. Okay, so now we are writing the conditions. So already I mentioned I1A should be equals to your I1B. So to give the common name, I just given with I1. And similarly for output side, I2A equals to your I2B, given with common name I2. And V1 should be equals to the sum of voltages I1A plus I1B. And V2 equals, that means your output voltage should be equals to the V2A plus V2B. Okay, so now from the equation number 1, we know what is V1A and V1B. So replace those terms, okay, those terms with your equations 1 and 2. So already we provided those equations. What is V1A and V1B? So replace those equations. So replace V1A and V1B. So here, so when you observe this, I have the element I1A and I1B. So I replace these two elements with I1, and I2A and I2B are replaced with I2. So here I am having the common element I1 and I2. So I am just taking out and I get the final expression as V1 equals to Z11A plus Z11B into I1 plus Z12A plus Z121, Z12A plus Z12B. That is the sum of port 1, okay, the sum of port 1 A network and B network. Z11 belongs from, for A network and B network are added. Similarly, Z12 of A network and B network are added. Similarly, if you perform for the second equation, that means by adding the second and fourth equations, you can get the similar fashion expression for V2 as Z21A plus Z21B I1 plus Z22A plus Z22B I2. So when I observe these two equations, okay, when you observe these two equations, it's similar to your standard Z parameters. So V equals to Z into I. So if I consider this standard Z parameters, okay, Z parameters, so this Z11 is nothing but your overall Z parameter. It is nothing but the summation of the Z11A plus Z11B. So by observing all the terms, I can say that only one word, the overall Z parameters, okay, the overall Z parameters for series connection, because this Z11A plus Z11B is nothing but the individual elements Z parameter. But here Z11 is the combination, entire circuit combination. How it will looking as, it is the sum of the both individual port parameters. So when you connected the element in series, okay, when you connected the elements in series, the Z parameters are nothing but the summation of those two networks, So similarly, we can go for the parallel connections as well as cascading connections in our coming videos. Thank you.